Okay, hello everyone. Let's get started on this review. So, page 1. Let's see. The function f is given by f of x equals 3 log of all of that. Find f inverse. So this is just a quick inverse question. Inverse, as always, start by swapping x and y. So we want to find out, this is going to be x equals 3 log base 2 of y plus 8. And now we just have to get y by itself and then label it as f inverse. So we're going to start with this 8 right here. So we'll move that over. So subtract 8 from both sides to get should be a 2 of y. Next we can get rid of this coefficient here, this 3. So that will bring us to x minus 8 over 3 equals log base 2y. Now we have to cancel out this log, so we will swing the 2 over and raise, this becomes the power. So 2 to the x minus 8 over 3 is equal to y. And then we would relabel y as f inverse of x. So that's kind of sloppy, so I'll just rewrite over here. F inverse of x is equal to 2 to the x minus 8 over 3. There we go. Next one, this is calculator active. So what is the solution? So we can use a calculator. What is the solution to the equation 4 times 2 to the x plus 5 minus 10 equals 22? Well, let's start by adding 10 to both sides. So we get 4 times 2 to the x plus 5 equals 32. Next, we have to get rid of this coefficient. So we'll divide both sides by 4. And so I get 2 to the x plus 5 equals 8. Next thing I need to do, I need to cancel out this base because I'm trying to get x by itself. So we'll take log base 2 of both sides to cancel that out. So we get x plus 5 equals log base 2 of 8. And you can either put that into your calculator, or you can just know that 8 is the same as 2 to the third. So this would be log base 2 of 2 to the third. Log base 2 cancels out base 2. And so you end up with 3. X plus 5 equals 3. Subtract 5 from both sides. X equals negative 2. There we go. Next, what are all the solutions of the inequality of this one right here? ln of x plus 10, ln of 5. Less than all that. So the first thing we need to do is we need to figure out our restrictions. So here, x plus 10 has to be greater than 0. That has to be a positive number. So x must be bigger than negative 10. And also 2x plus 17 also must be greater than 0. So in that case, we subtract 17. 2x is greater than negative 17. And then divide by 2, x is greater than, I'm going to make this a decimal because it's easier to see on a number line. So negative 17 divided by 2 is a negative 8.5. So let's draw our number line. Make sure you always draw this number line. It makes things much easier to see. So negative 10 is right here. And that's going to be open. And we need everything bigger than negative 10. And then I have negative 8.5, which is a little bit bigger, so I'll make this right here, negative 8.5. And we need everything bigger than negative 8.5. So we need anything bigger than, right now, anything bigger than negative 8.5. So now let's solve this. ln of x plus 3. Rewrite the problem. ln of 5 is less than or equal to ln of 2x plus 17. So let's merge these two on this side right here. So we would get 5 times x plus 10. So I'd get the natural log of 5x plus 50 is equal to the natural log of 2x plus 17. The natural log is on both sides now, the single log on either side, so they cancel out. So I get 5x plus 50 is equal to 2x plus 17. We'll subtract 2x from both sides to move it over here. So this side will be 3x. I'm going to subtract 50 from both sides to move all the constants over there. So this will be equal to negative 33. Divide both sides by 3. Oh, sorry, this shouldn't be equal to. This should be less than or equal to. Divide both sides by 33, and so we get x is less than or equal to negative 11. So negative 11 is right here, and we want everything less than or equal to, so that is in this direction, less than negative 11, and we can see that none of these overlap. We want where all three overlap, and they don't. This one has 2 spots, but so this one is going to be no solution because there is no intersection. Okay, next up. Another calculator one. Mr. Sullivan used to collect football cards when the Cleveland Browns drafted Johnny Manziel. He knew his rookie card would be worth a lot of money over time. So he kept track of the value after every game Johnny Manziel played, and the data is below. So after 1 game, it's worth this much, 3 games, and then 4 games, and 9 games. So what's a logarithmic regression line to model this equation? So we're going to go over here, since we can use a calculator. We're going to look at Desmos here and add this data in. So that's 1, 3, 4, and 9. And then the other side is 57.5, 37.77, 32.74, and 18.55. And then they said they wanted a logarithmic regression line, so we'll go down here to logarithmic. And then we will paste that right there. We're going to go ahead and change this from from y to f of x, just to make things easier. Okay, our data is in there. So, what is the logarithmic regression line here? The logarithmic is going to be 57.400 minus 17.736 natural log of x, ln x, okay, is equal to f of x. Now, how many games would Johnny Manziel need to play for his card to be worth $10? So we're going to set this entire thing equal to $10, and then we can solve it. Or since we have a calculator, 10 is a y value, so we can say y equals 10, and we can see where these two lines intersect. So we go over here, and we can see they intersect right there. So after 14 and a half games, or after 14 games, or after 15 games, his card would be worth about $10. And if you, let's say that didn't work, like let's say this was way off in the distance, like you didn't want to scroll all the way over, you could always set everything equal to the function. So you would say something like 10 is equal to, and then you would say all of this here, 57.400 minus 17.736 ln of x, and then you could solve it. So you would subtract 57.4 from both sides, you divide both sides by negative 17 point that, and then raise it to the eth power. or sorry, make that e the base. But eventually we get that x would be equal to, or about equal to, 14, when I say, go back, check my calculator, 14.477 games. There we go. Okay. Let's go ahead and stop it there, and I'll close off that video and start a new one.